Hello, everyone.
Hello, hello.
Are we live yet?
I think we'll go live at 5:30 if I'm not mistaken.
Okay.
So we'll just wait a few minutes, let some people join.
Fatima, did you get the agenda I made up in that Google Doc?
I have not. I think Jeannie might have.
Okay.
Let me check it out.
I'm not going to go over every link in that. It's just some reference. I'm going to go over the first two sections and refer briefly to the last.
Okay, awesome.
Hey, Phil, thanks for joining us from space.
If I could ever figure out how to put a green screen on my computer, that's what my background would be.
Great to see you, Victoria.
Great to see you too, Philip, and everyone else.
So we'll just wait another minute or two and see if anybody else is going to trickle in.
Welcome, Dr. Dodek.
Hi, everyone.
Hello, Dr. Dodek. I've heard a lot about you. It's my first time actually meeting you.
Well, thank you. I hope it's all positive stuff.
All positive stuff.
Well, let me know how I can help. I'm happy to help this cause in any way that I can, including that guy on the moon over there.
He does appear to be in an actual space station, bumping along up in the atmosphere.
I think he's doing a spacewalk, actually.
And let's hope he's tethered.
Just give it another minute, see if anybody else is going to join.
Sorry, I just want to ask, Victoria, are you able to share your screen right now or not?
Yes, I will be doing that.
Okay, awesome. Also, Peter, are you there?
Yes, I am. I just don't have my camera on right now.
Okay.
Okay, so it's 5:33 now, so I think we're pretty safe to begin. So, hi everyone, welcome. Thank you for joining us at our monthly COSMIC Symposium. So our name is the Collective Open Source Medical Innovations for COVID-19, or COSMIC, and we are a nonprofit organization of over 100 volunteers with the mission to create abundant access to medical equipment in BC and around the world through open source design solutions. So right now we are recording and live streaming live to Facebook. My name is Alexander Waslin. I'm a fifth-year mechanical engineering student at UBC, about to graduate this May. I was one of the founding members of COSMIC just over a year ago now, and I'm currently on the board of directors of the organization. Very excited to be here with you all for our monthly symposium and community update. So this monthly symposium is supposed to be a chance for us as a COSMIC community to meet, hear some updates about the inspiring work and progress that our projects are making, and hear from guest speakers in the world of open source designs for medical supplies. So this week, we have the opportunity to hear from Victoria Jaqua. Victoria is a registered radiology technologist specializing in cardiac catheterization. When not working her clinical job, she is the medical team co-lead for open source medical supplies, or OSMS, which I'm sure we've all heard of, where she supports the Maker Medical Connection, especially for traditionally underserved populations. So before we get into the main thick of the symposium, I encourage everybody to turn your camera on, give a quick wave to your other COSMIC community members, and we'll try to catch a picture of everybody who could join today. So 3, 2, 1. And we'll do one more. Perfect. Okay, great. So without further ado, before we hear from Victoria, I'd like to jump into some of the updates of our project teams and hear what they've been up to over the past month. So first, I'd like to see if somebody from Bubble Helmet could give us a quick update on what the Bubble Helmet team's been up to.
Sure. So my name is Fiona. I am the co-leaders for the project Bubble Helmet. Can you guys hear me? Good. Okay. So just a quick presentation to remind us all about what is the COSMIC Bubble Helmet is. It is a non-invasive positive pressure ventilations. The project started when the pandemic started in March 2020, and we want to provide this solutions for respiratory support for patients suffering from COVID-19 with method that is not commonly used in North America, and we saw it is effective in Italy, and we set off on this journey to bring this technology that we developed into the patients. This is an example of the COSMIC Bubble Helmet that is currently in use by one of the critical care physicians in Vancouver General Hospital. It is a non-rigid ring. So you can see here, the bubble helmet is single materials and is a result of product developments across engineers, medical doctors, and students all over Canada. So the benefit of our project is that the helmet is a simple technology that can deliver a positive and expiratory pressures to help patients with respiratory distress. It allows patients to lie prone in critical care settings that help patients with their breathing as well. And because the whole system is contained and has filters near on the inlet and the outlet, it minimizes the risk of viral aerosolizations. It reduces. And the helmet technology itself has been shown to be effective in reducing intubations and mortality rates in patients with acute respiratory distress syndromes. And recently, an article in JAMA showed that it is in COVID-19 patients specifically, when compared to high flow nasal oxygenation, it does reduce the intubation rate by about 20%. So it seems to work, and I think our design that is easily manufactured and very simple and improve patient comfort due to the 100%, almost 100% transparency from the hood, the ports, and the neck seal would be great additions to the options that Canadians or any patients in the world that requires respiratory supports to have an options as a medical device. So it also has future potential applications such as the post-operative treatment for sleep apnea, oxygen delivery inside hyperbaric chambers, and also alternative NIV interface for patients that does not fit the traditional mask. And also can be used for personal protective air preferring respirator interface. So the update in the past month is that we received a $25,000 support from the Weston Family Foundations. We are very grateful for the support, and this amount of money will help us propel the project forward and achieve the next stage. And another great news is that we are selected as a finalist of the MDDC Awards for Excellence in Biomedical Engineering and Seal Design and Innovations. We will present on April 24th, which is next week. And hopefully we can win this award as well. So currently in the next month or so, we will continue to optimize the design in terms of where is the best port locations, the user experiences, and also we are compiling files and the necessary documentations to hopefully apply for Health Canada interim order so that we can move forward and reach the next step to provide this technology to patients. To apply for the Health Canada interim orders, we need to have a manufacturers that are certified or comply with the GMP. We are in the process of talking to what manufacturers, but if you have any other leads in terms of people who are able to help us in facilitating our applications and the process in getting approvals and the distributions in the future for post-marketing, we are very interested to talk to them and to see how can we bring this project into the patient's hand. Thank you. And these are our many members and many more of us that are no longer with us and people who will join us in the future.
Awesome. Thank you, Fiona. That's very exciting that you guys have won that award and are finalists of that competition. It's a reflection of all the hard work that the Bubble Helmet team has been doing over the last year. Very inspiring. So I think we have time to maybe, if anybody has any questions for the Bubble Helmet team, to have a short Q&A, if there's anything that anyone wants to ask. Otherwise, we'll move on to the next team.
I just have a comment, Alex. For those that don't know me, I'm a resident physician. Currently, I'm doing a rotation at St. Paul's Hospital ICU, which I think at one point Dr. Dodek was the director of. And one interesting note is we are currently cohorting our patients, where in a sense that we're separating patients with the Brazilian variant of COVID from patients with the old version of COVID, because there's a concern that the Brazilian variant of COVID could infect patients that are currently have the old version of COVID or have even developed immunity to it. So there's increased concern about transmissibility, and for that reason, I feel all the more enthused by the potential of the bubble helmet as a means to reduce the risk of transmission and kind of increase capacity of our intensive care and hospital units accordingly.
Yeah, thanks for that update, Phil. It sounds like the work that COSMIC is doing continues to be very important. So next, I think we can get a quick update from the oxygen concentrator team, if there's somebody from that team who wants to speak about the progress in the last month.
Sure. I can open up the PowerPoint and all right. So as we know, based on the current demand due to COVID and even after post-COVID, there's going to be a large demand for the oxygen concentrator. Keeping that in mind, we are in the process of developing our own version of the oxygen concentrator, and our main innovator, Bruce, is going to speak a little bit more about the design that we're trying to develop. Bruce?
Oxygen concentrators have been around for about a half a century, so it's established technology, and yet the worldwide shortage in oxygen has persisted. And this is despite large amounts of money buying lots of machines and sending them to where they're needed. They tend to have a very short operational life, usually about a year, because they're designed in the developed world for conditions here in terms of the power supply and availability of maintenance. And it's kind of sad that most of these machines end up in the equipment graveyard out behind the hospital after about a year, and for a number of reasons. So what we're trying to do is engineer a machine with engineered in robustness, so it doesn't require the maintenance and high quality power source that the existing machines do. So we're pursuing this. There's a number of technical aspects to the device that will hopefully solve some of the problems. We're not there yet, but we're making steady progress in a number of areas. So if there's any questions about the device or where we're at or why we haven't produced the perfect oxygen concentrator, I'd be happy to answer.
Thank you, Bruce. So based on that, we're working on, so this looks like a little bit of a roadmap, working prototype testing. We'll go through the regulatory approval and hopefully deploy these devices to the people who are in need. And this is a snapshot of our team, although there are some more people who will be joining as well. So yeah, if there are any questions, please ask them.
If any questions, oh, sorry, Phil, go ahead.
I think you alluded to the prototype being partly done. I guess my question to you guys would be what are the additional steps to complete the prototype?
Well, the prototype concentrates oxygen. It's not as high a concentration as we would like. So we're working on instrumentation to kind of drive up the oxygen concentration. There's a number of innovations that require integration with the control system. All the machines on the market use timed cycles. So the designers determine what's the optimum time for the machine to cycle through its performance. Unfortunately, when that's done in a factory in Belgium or something, and then the device is loaded on a plane and sent to the Sudan, where the humidity and temperature and everything is different, then the optimization doesn't work. So one of our innovations is the design uses oxygen sensors so that it self-calibrates on a continuous basis every cycle to run as efficiently as possible. And this is the type of thing that we have to integrate the sensors and control systems. And so that's the type of thing that we're working on at this point.
Thanks for the update there.
Okay, if any other questions come up, feel free just to send them in the chat. Let's see one from Austin here. The question is, have you been able to do any test runs with the sensors yet?
Yes, we routinely use the sensors, and they have the sensor devices have a digital readout on them, so that we can manually cycle according to the numbers that appear on the screen. What we'd like to be able to do is to take the digital readout and send it directly to the Arduino, so that the Arduino does the switch flicking.
Okay, great. So finally, I'd like to call upon our newest project, the algae rebreather, which is a pretty exciting concept. If there's anybody from that team who can give a quick update on what that's all about.
All right, yeah, I'll go ahead and share my screen. Hi, so I'm Katya Bernard. I'm one of the new contributors to the Algae Rebreather project. The primary function of this, here, let me just move my Zoom out of the way. The primary function of this bioreactor is to remove carbon dioxide from exhaled air while simultaneously producing oxygen, so that exhaled air can recirculate and be rebreathed. This design can significantly increase the amount of patients treated by an oxygen concentrator, and we're decided to use algae because it's easy and quick to cultivate. Its pigments are extremely efficient in light harvesting, and it's very efficient in converting light to oxygen chemical energy. Our organism of choice is Chlorella vulgaris, and right now we're determining the environmental parameter limits, the human requirements and parameters, while following CDC regulations. Here are two of our design options that Patrick drew up. Case 2 or option 1 is an oxygen concentrator and an algae rebreather that includes CO2 scrubbing. And case 3 or option 2 includes algae O2 production and the rebreather without the oxygen concentrator. So the question we're trying to answer is if this is a viable pathway to O2 production. And our current objectives are to begin growing an algae culture with LED lights, determining the optimal bioreactor conditions and parameters, while also experimentally determining the C. vulgaris oxygen production rates and the most efficient and sustainable way to cultivate algae. So thank you so much. If you have any questions or comments, please feel free to reach out, and I can either try to answer them or shoot them to Patrick or Bruce or team lead Kenny. Yeah, so thanks again. I'm really excited to join this team. And yeah.
Awesome, thanks for the update. That's a very exciting new project that we got going on. Open the floor if anybody has any questions they'd like to ask. Okay, if any come up, feel free just to send them in the chat, and we can get around to answering them at the end. So with that, I'd like to thank all the projects for their updates, and now I'd like to turn the mic over to Victoria, who will tell us about what OSMS has been up to, as well as some other developments in the makerspace for medical supplies.
Hi, everyone. It's really wonderful hearing all the updates and knowing that COSMIC still is going strong with all of your projects. I'm going to share my little agenda document again. Our most exciting development from OSMS is the documentation of the maker medical movement from last year. And I'm going to share my screen. Let's see, where are my tabs? Right here. So OSMS worked with Nation of Makers and also received data from the Fab Lab Foundation, collecting data about the amazing effort of maker spaces, Fab Labs, individual makers, university maker spaces, and retail manufacturers to make PPE. And this very impressive number of 48.3 million units delivered at an estimated replacement value of 271 million is only a portion, because this is only what was reported to us. It is assumed that so much more was done that we did not collect data on. But this is what was reported to us, and this is the report about it. This is a massive report. there's presentation slides, as you see here, and there is our actual paper. Back in April, we came across this quote from a physician in New York. Just randomly, it came across our screen, and we saved it, and it went into the report in January. So from April 2020 to January 21. This is why the maker movement happened. It's because physicians did not have the protective equipment to treat patients. And it was really cathartic to hear a physician talk about how important the work of the volunteers and the makers and the designers was. And he says within several days, he went from having no face shield to having a face shield. It was really amazing to find this quote. So it was a privilege to be able to protect our medical community during this time. And I just want to point out some really impressive parts of the response. The makers really focused on under-resourced communities, and we were able to get PPE to tribal locations, social service locations sooner or 100% before other PPE efforts arrived, if they arrived at all. This is especially true for the tribal community and rural hospitals. For rapidity of response, there are many instances of maker groups getting PPE into a hospital or valves into a hospital within 48 hours. You just can't get much faster than that. And this happened not only just making things, but I'm going to go down to a graph here. Our weekly production count shows how the response kept level with the rise of COVID in the first spring surge in the United States. And one of my favorite statistics is the growth rate. In 5 weeks, the maker output was 653%, a 50 times faster growth rate compared to the 3M production of N95 masks. So you compare, you know, a large corporation such as 3M that has buildings and employees and equipment in place, and you think about their output compared to the maker output, who had no previous designs. These designs were created as the event was rolling along. They created distribution networks. They set up production lines. They educated themselves about these new products they were producing. And they got these supplies into the hands of hospitals, doing all of that at the same time, ramping up production to that level. It's absolutely mind-boggling. So we have several places where you can read the report. There's webinar, presentation slides, and it's also on Medium. I just wanted to touch briefly on some news headlines regarding oxygen. I know that last summer and fall, COSMIC and OSMS collaborate a lot with obtaining information about a possible upcoming oxygen shortage. And everything that we feared is coming to pass. I know this goes in English. All right. This is ICU in Peru that ran out of oxygen, and all the patients in the ICU died. This did translate for me in English. I apologize. The same thing is happening in Brazil. And in addition, Brazil is running out of paralytics and sedatives to intubate patients. And I know all of you are very familiar with the P1 variant, so I won't get into that. But it's a really serious situation in Brazil. Because of this, I am putting a lot more focus on the slow admission amongst the medical agencies that this is an airborne virus. And although masking certainly is an important preventative, I feel like there needs to be a lot more focus on how we prevent aerosol transmission. I also know that in BC, you may not have an HVAC system or central air in a building, and a lot of people have box fans. So I've included some links at the bottom on how to DIY an air purifier as a backup if you don't have a HEPA filtration system. And the Lancet study literally came out today with some important bullet points about airborne transmission. My internet is slow, I guess. I apologize. And this high-level document is written by all of the authorities on airflow and airborne transmission prevention. These are all very highly educated with pretty much every question you could want answered about airborne transmission is in here. And I thought Section 9 had some good action items on monitoring CO2 levels and the parameters around that. So I'm hoping that some of these links are beneficial to you all. And I have to get back to my screen, and I don't know how to do that. So there we go. Any questions?
So those were some very inspiring numbers that you showed in the beginning there about the how many millions of maker-produced products got into the hands of those who need them. I'm just wondering what the challenges were with actually trying to quantify those numbers in terms of actual data.
We put out very specific community surveys. We actually started doing production tally surveys March 28th. That's where that graph came from that I indicated. March 28th, we started to tally community, and they self-reported. They would show pictures, really large production lines, you know, that reported like 100,000 or 50,000. We requested they submit spreadsheets. So we did everything we could to make sure that this data was accurate. So we combined that data with our community impact survey data that was, I believe it was started in October of last year. And we collected data from that for about 2 or 3 months, I think. And we requested the same photos, spreadsheets, anything that could prove production level. And you didn't have to be a big producer to be part of the survey. If you were one person in your house making masks and you made 50 masks or 20 masks, you were still counted. Anybody who reported to the survey and was verified was included in the survey. Because an enormous percentage of makers, off the top of my head, I think it was like 81%, had less than 50 people in the production line. And there were many individual makers that churned out masks and ear savers. There was one maker that made over 100,000 ear savers on his 3D printers. So people were very dedicated to this, and the ability to connect with the community on Facebook was very important. It provided connection for people who were in quarantine, who needed mental health support, design support. A lot of people said the tally that we did in March, April, I think it went into May as well. We did it every Friday, was the one bright spot in their week, that they could connect with everyone else around the globe who was helping at the same time.
That's kind of a drop the mic moment. That's very powerful, and I think OSMS was, catalyzed that coming together of community. And I think it's worth highlighting for everyone here that OSMS has open source in its name, as does COSMIC, and so we have a very similar ethos. And I think that's one of the many reasons why we were thrilled to have Victoria come and speak to us today. And I think it's really compelling, as Alex alluded to see the impact that these designers, makers were able to have by sharing the designs, and just kind of everyone coming together at a very singular time in history, which was the first wave of COVID, and then continuing on. So thanks, Victoria, for both sharing some really compelling statistics, but also some great anecdotes.
Well, open source saves so much time, because you don't have to keep reinventing the wheel. And if you've gone 3 steps in a design and you share that with someone else, they can start at step 3 instead of having to start at step 1. And that's why we've documented as many designs as we can in our library. We've really focused on preserving data. The designs are just so important to save. And that we referenced in the report at the end of March, there was a face shield that was a kind of a redo of the famous Prusa face shield. It was the DTM face shield, and it was approved by the NIH. And when that face shield went up on the NIH website, it crashed the servers. They reported a 6,000% increase in access to the server. So that's really impressive. And that approval of that maker-made design trickled down through the whole ecosystem of the maker movement. It influenced other designs. I found a face shield that had a 3D printed band, but the visor, which the DTM face shield had 3D printed, they turned that visor into a clear section. So they had to use less filament. Just the innovations, the creativity, it was just astounding what everyone came up with.
If anybody else has any questions they'd like to ask Victoria or any of the other project teams who spoke, feel free.
I'd just like to put a general plug in for COSMIC with regards to the synergy between the projects that we work on. Particularly the relationship between the bubble helmet, the algae project, and the oxygen concentrator project. When you try to put an oxygen concentrator in an isolated hospital, the cost of the oxygen concentrator is dwarfed by the cost of the power system that's required to support it. A solar-powered battery backup to run one of these oxygen concentrators, typically costs 10, 20, 30 times as much as the oxygen concentrator. And everybody focuses on the oxygen concentrator, but the cost is the enormous cost of processing bad power or supplying solar power. And anything that can be done to increase the efficiency of the usage of the oxygen drastically reduces the cost of the power that's required to support it. So for instance, the algae project, if they can make a functioning rebreather system, it increases the number of patients that can be supported by a single oxygen concentrator by about 400%. So one oxygen concentrator is serving like a small ward instead of one person. The bubble helmet would be ideal for capturing the exhaled oxygen to be run through the rebreather. So all these products, you know, assist each other and, you know, synergistically. So I think it's really kind of cool how the projects come together.
Yeah, that's a great point, Bruce. Thank you for bringing that up. The ability to see where one project might have a pitfall and then spin something else up to try to address that's pretty inspiring part of this whole movement. Okay, well, I think that pretty much concludes the formal part of our design symposium tonight. So thank you to everyone for joining. I'd like to invite anybody who wants to stick around for a few more minutes and just have some conversation with the COSMIC community to feel free to do so. But other than that, I think we'll stop the live stream and hopefully see everybody in another month.
Thank you, Alex. Goodbye for those who are jumping off now.